I also, from exercise 5.5 for Cramer's rule, you should be trying to solve question number 1, 2, and 3. So let's take a look at question number 1. So all four parts of it, A, B, C, and D, gives you a system of 2 by 2 equations. So basically 2 equations and 2 variables. And you guys have to find the values of the variables using Cramer's rule. So it should be simple enough, and I'm not solving anything from here. So you guys give it a go and see how it turns out. In number 2, what you have to do is use Cramer's rule. No, so you're going to use the questions given in question 1, but instead of using Cramer's rule, you're going to use matrix inversion method to find the values of x1 and x2. So we've talked about this in our previous lecture, and hopefully all of you remember how to use matrix inversion to solve systems of equation. One hint, it's not really much of a hint, it should be obvious to you guys already, is that your answers in question 1 and question 2 should match. If they do not match, you've made a mistake somewhere. So in number 3, you have 3 by 3 systems of equations. So 3 equations, 3 variables, and you have to find the values of x, y, and z using Cramer's rule. So once again, it's pretty basic. We've talked about this just in our previous video. So I'm going to go through this very quickly. I'm going to do 3C. So this is what we have. Equation 1 is 4x plus 3y minus 2z equal to 1. Equation 2 is x plus 2y equal to 6. And equation 3 is 3x plus z equals to 4. So this is slightly different from what we have done so far. So before you guys see me solve this problem, I'm going to ask all of you to pause this video right now and try and solve this. First step, obviously, is to convert the system of questions into the matrix form. So please do that. Pause the video right now. Try to solve it yourself. And once you've done that, or if you can't solve it, once you've at least tried for a number of minutes to solve it, come back and see me solve it. Okay, so the thing to realize here is that equation 2 and equation 3 do not have all the variables. So we can rewrite equation 2 in this form. So x plus 2y plus 0z equal to 6. It's 0. So it doesn't matter if you're adding or subtracting or whatnot. And equation 3 can be rewritten as 3x plus 0y plus z equals to 4. So effectively, this and this is not given in the equation. So when you're trying to convert this into a system of equations, a common mistake might be to write it in this form: 4, 3, minus 2, 1, 2, 3, 1. You don't know what this and this is, so you put 0, x, y, z equals to 164. Now this is wrong. This is completely wrong. And once again, if it's not obvious to some of you why this is wrong, please pause the video and try to figure out why this is wrong, and take some time, take a few minutes, 5-10 minutes, and see if you can figure it out. The reason why this is wrong is because this right here, this is the value of z. So what we want in first column is all values of x, all values of y, all values of z. That's how the columns are arranged. And for the rows, first row is the first equation. Second row is the second equation. Third row is the third equation. As a result, this one right here does not belong here. So the correct way of converting this system of equations into the matrix form is to write 4, 3, minus 2, 1, 2, 0, 3, 0, 1. Now all the x's and the y's are aligned. And then we have x, y, and z. And on this side, we have 1, 6, and 4. And this is what we wanted. And now what we are going to do is use Cramer's rule to find the values of x, y, and z. So once again, if we call this matrix A, determinant of A is given by, okay, let's see, which one might we use? I'm going to decide to use the third row. Up to you guys, obviously, which row or column you want to use. So what I get is 3 minus 2 to 0. I have a 0 there. I'm not bothered with that. Plus 1, 4, 3, 1, 2. Okay. And that gives me, so 0 plus 4 plus 1, 8 minus 3. So determinant of A is 17. And now I'm going to construct AX, AY, and AZ. So AX is going to be 1, 6, 4. I'm replacing the first column, and then 3, 2, 0, minus 1, 0, 1. AY is going to be, first column remains the same, replacing the second column, and AZ is going to be 413, 320, replacing the third column, 164. Once we have this, I can calculate the determinant of AX, which is, I'm going to once again use the third column. So that will give me 4, not this, determinant, 3 minus 2, 2, 0, plus 1, 1, 3, 6, 2. Okay, so what this gives us is 16 minus 16 minus 16. So determinant of A is 0. That's interesting. That's odd, but all right, let's carry on. See what happens. Determinant of AY will be, I'm going to use the third column. Once again, it's up to you guys which one you choose to use. So minus 2, 1, 6, 3, 4, plus 1, 4, 1, 1, 6. So this gives us 28 plus 23. Okay, so that gives us 51. Okay. And the determinant of AZ will be, and if I look for the easiest one, this looks like the easiest column to me. So 3, 3, 1, 2, 6 plus 4, 4, 3, 1, 2. So that gives me 18 minus 2 plus 4, 8 minus 3. So 16 times 3, 48 plus 28. So that is 68. All right, so what we now know is that, how much was it? So determinant of A is 17. Determinant of AX. I'm going to check this calculation again because it's odd that this is 0. AY is 51 and AZ is 68. That's not, it's 68. Well, the calculation seems fine. I just paused the video and checked. So I suppose AX is 0. Okay, it can be 0. So now we try to find the value of X, Y, and Z. Okay. So X is given by, remember, this divided by this. That is what? 0 by 17 equal to 0. Y is given by this divided by this, which gives us 51 divided by 17. So that's 3. And Z is given by this divided by this. So 68 by 17, that gives us 4. So what we have is X equal to 0, Y equals to 3, and Z equals to 4, and that's the answers. Okay. So you see, Cramer's rule in itself isn't that difficult because we've already learned how to calculate determinants in the last lecture. And Cramer's rule literally is just calculating determinants and then dividing one determinant by another determinant. So it's easy enough. So this is then the end of your matrix syllabus. I think I've already talked about what's coming in the next lecture, the quiz and the assignment, so I'm not going to go into that again. Practice, that's all I'm going to tell you all. Some of you may be already confident that you understand matrix. For those of you who are not, this is a maths course. The best advice I can give to you is to practice. That's really it. So get to it, and good luck for the coming quiz and the assignment.